Welcome to the DIY Honda Garage channel. DTC P16F4 indicates a low voltage condition in the starter cut relay 2 control circuit of the Honda CR-V 2023 and newer models. The starter cut relay plays a crucial role in preventing the engine from starting under certain conditions, possibly to ensure safety or compliance with emission standards. When the engine is off, this system checks the voltage in the circuit. If it detects a low return signal from the starter cut relay 2, the powertrain control module, PCM, logs the issue. This can affect the vehicle's ability to start or operate correctly. Accurate diagnosis is essential for identifying the root cause, as the starter cut relay, PCM, and associated wiring all play integral roles. Next, we will delve into the specifics of this DTC to guide effective troubleshooting. The starter cut relay 2 is designed to manage the electrical flow related to the vehicle's starting function, serving essentially as a safeguard against unintended engine starts. Located on the relay circuit board, it operates under the guidance of the powertrain control module, PCM. When the engine is off, should the relay return a low voltage signal, it indicates a malfunction or wiring issue, prompting the PCM to store the DTC P16F4. The PCM, acting as the brain of the vehicle's electronic control systems, continuously monitors various components, including the starter cut relay, to ensure they operate within specified parameters. If a discrepancy is found, the DTC is triggered, indicating the need for further inspection and troubleshooting to rectify the issue. Proper understanding of these components and their functions is pivotal for effective vehicle maintenance. There are several potential causes of the DTC P16F4 that could prevent the starter cut relay 2 from functioning correctly. First, issues in the external circuit, particularly with the wiring leading to and from the relay and PCM, can lead to abnormal voltage readings. Next, a malfunctioning PCM itself could falsely interpret normal conditions as low voltage, thereby setting this DTC. Additionally, the wiring may have become shorted or open, affecting the integrity of the circuit. Lastly, the relay itself may have failed mechanically or electrically, not allowing it to operate as intended. Each of these possibilities should be examined in order to accurately diagnose the problem. The symptoms of DTC P16F4 can manifest primarily as an inability to start the engine. This is the most recognizable sign, as the starter cut relay prevents the engine from engaging. Additionally, there may be poor electrical performance within the vehicle, leading to behaviors such as dimming lights or unresponsive electronics, as the voltage drop may affect various systems. Drivers may notice that the DTC has been stored in the PCM, often accompanied by warning lights on the dashboard indicating a malfunction within the starting system. These symptoms provide critical clues that assist the technician in pinpointing the underlying issues related to this code. Assessing these symptoms can help guide effective troubleshooting steps to resolve the problem. The first troubleshooting step involves turning the vehicle to the on mode. This action allows the PCM to perform initial checks on various circuits, including those associated with the starter cut relay 2. It's essential to monitor the behavior of the relay at this stage, as the system should ideally signal normal voltage levels when the vehicle is in this mode. If a low voltage signal is detected during these checks, it corroborates the stored DTC P16F4 and suggests the need for further investigation. This step effectively sets the foundation for subsequent diagnostics, enabling the technician to focus on the circuitry linked to the relay and the PCM. In the second troubleshooting step, the technician should carry out a thorough inspection of the relay circuit board where the starter cut relay resides. This involves checking all connections to ensure they are intact and free from corrosion or damage that could lead to signal disruptions. It's crucial that the socket connections and wiring are secure, as loose or deteriorated connections can often be the source of low voltage readings. The inspection should focus on both the visual examination and any additional tests that could reveal faults within the circuitry. A meticulous approach here can often uncover issues that directly influence the relay's operation and overall vehicle performance. In the third step of troubleshooting DTC P16F4, the focus shifts to verifying the voltage throughout the circuit. The use of a digital multimeter can help measure voltage levels accurately. Following the voltage checks, it is also essential to perform continuity tests on the wiring associated with the starter cut relay 2. This involves checking for any breaks in the wire that could lead to open circuits, thereby contributing to the low voltage signal reported. Investigating open grounds is equally important, as these can significantly disrupt circuit performance. Lastly, recording each measurement and comparing it against manufacturer specifications will guide the next steps towards isolating the faulty component. The fourth step in troubleshooting DTC P16F4 involves assessing the powertrain control module, PCM, itself. This includes checking its behavior and ensuring it is correctly interpreting signals from the starter cut relay 2 and the associated wiring. The technician should also examine any additional DTCs stored in the PCM that may point to related issues. If the PCM is unresponsive or continues to log DTC P16F4 despite having passed prior inspections, it may necessitate a replacement. Considering the PCM as a potential source of error is critical. Substituting it should only occur after exhausting other troubleshooting avenues to avoid unnecessary component replacements and costs. Final verification of repair regarding DTC P16F4 should begin with clearing the DTC from the PCM once all suspicious components have been either repaired or replaced. A successful clearance indicates that the PCM will no longer flag the issue unless it recurs. Following this, it's essential to conduct a test drive of the vehicle to observe its performance under normal operating conditions. During this process, the technician should actively monitor the dashboard for any warning lights that may indicate issues. After the test drive, it's vital to scan the PCM again to confirm that DTC P16F4 or any other related codes have not returned, ensuring the integrity of the system has been restored. This step validates that the troubleshooting process was successful, ultimately leading to lasting vehicle performance. To prevent the recurrence of DTC P16F4, regular preventive maintenance is crucial. This includes consistently inspecting wiring associated with the starter cut relay and PCM connections, ensuring that they remain free from wear or damage. It's equally important to check the relay's functionality periodically, as this component is subject to fatigue over time. Additionally, maintaining clean and secure electrical connections can help mitigate potential voltage drops that may lead to future issues. Scheduled maintenance checks should incorporate these focus areas, enabling vehicle owners to catch and rectify any abnormalities before they result in a malfunction. By adhering to these preventive practices, the longevity and reliability of the starter system can be significantly enhanced. In conclusion, understanding DTC P16F4 is essential for maintaining the starting system of the Honda CR-V 2023 and newer models. This code flags an important malfunction in the starter cut relay 2 control circuit, necessitating a thorough inspection of both circuit behavior and the components involved, such as the relay and PCM. Key components play specific roles in ensuring proper function, and recognizing their interconnections can greatly aid in effective troubleshooting. A systematic approach to diagnosing and repairing the issue along with adhering to a regular maintenance schedule, helps to prevent future occurrences of this DTC. Ultimately, these practices ensure the reliability and efficiency of the vehicle, reinforcing the importance of timely attention to diagnostic trouble codes. Please like and subscribe to the channel. See you next time.